I'm not sure if you can hear, but my parents are currently watching some Chinese drama right now, so if you kind of hear some background noises, apologize for that. So, okay, so in today's video we have this limit. So the limit as x approaches infinity of ln of x divided by x that's being multiplied by the integral of from 1 to ln of x of e to the t multiplied by t to the negative 1 dt. Okay, let's do it. So the obvious thing that we should do is, take the limit. But as you notice, if we do take the limit as x approaches infinity, we get an infinity over infinity indeterminate form. So the best choice to do this is we would have to take L'Hopital's rule and then take x approaches infinity after taking those derivatives of the numerator and the denominator. But the numerator and the denominator, how I'm going to define that. So I'm going to define functions, let's say psi of x to equal ln of x, and then multiply by the integral from 1 to ln of x, e to the t times t to the negative 1 dt, and then I'm going to let 5x equals x. Okay. So now this means, since we have a infinity over infinity indeterminate form, that means we need to use L'Hopital's rule. So in this case, take the derivative of the top, and then take the derivative of the bottom, and then take its limit from there. So that means we need to take the derivative of this. So before taking the derivative of using the product rule, what I want to do is let's actually focus on taking the derivative of this, just the integral first. Okay. So what we know is, okay, so I'm actually going to write the del of x of this integral, but what I want to state is what we know is that if we have some, for the bounds, if we have some constant a and then a variable x of f of t dt, it should be familiar to you guys if you're taking calculus 2 that this is actually the fundamental theorem of calculus. So that means inside the brackets there exists an antiderivative, so we're going to call that capital F of and then evaluate at its bounds, so it's from capital F of x minus capital F of a. But therefore, if we were to take the integral, if we were to take the derivative, the partial derivative in respect to x, capital F of a is just some constant, so that cancels. But then capital F of x, if we take its derivative, its partial derivative in respect to that, we just get that it's actually just equal to f of x. So we're actually going to apply this in order to evaluate this integral. Okay, so that means I'm going to fill in, so del of x, and then we have, what was it, 1 ln of x, and then e to the t times t to negative 1 dt. So to put it simply, this is the antiderivative of this, which is just capital F of ln x minus capital F of 1. Okay. And another thing we should consider is when we take the derivative of this, notice that it's in composition. So we have a function inside of a function. So that means note that this is actually chain rule we're actually going to be using. So note that chain rule is defined as d of x of f of g of x. I'm just using some arbitrary f and g functions, so that's equal to the derivative of f divided by df dg, then multiply by dg dx. Okay. In other words, this is how the standard formulation looks like to you guys. So f prime of g of x, then multiply by g prime of x. Okay, so when we do this, so when we apply the chain rule to here, so yeah, I'll write it. I'll keep going over here. So del of dx of f ln of x minus capital F1. So when we take the chain rule, so simply this is actually I'll write it down here. This is when we take the derivative of capital F, we're just back to f, stated from here, and then plug in our ln of x. So this is just f times oops, it's supposed to be inside. So this is supposed to be f of ln of x, and then take the derivative of the inside of, which is the derivative ln of x, which is just 1 over x. So this is just f of ln of x divided by x. But let's evaluate f at ln of x, which is here. So e to the ln of x is just x, and then t to the -1 is 1 divided by ln of x. So this is, what did I say? So this is x, then divided by, then x times ln of x. X is canceled out, so we get that it's 1 over ln of x. So this means the derivative of this integral right here specifically is actually equal to 1 over ln of x. So now that we have that, now we can actually take the derivative of our psi function using the product rule. So we know from product rule, so we take ln of x. So obviously you guys know product rule is f prime of x plus g of x plus f of x times g prime of x, and it's commutative, so it doesn't matter which way you write it, you're still going to get the same thing. It's community under addition. So derivative of ln of x is just here, let me write this, x, share this. So the derivative of ln of x is just 1 of x, then multiplied by the integral from 1 to ln of x, e to the t times t to the -1 dt, okay? And then plus ln of x, which is, yeah, just ln of x, and then multiplied by the derivative of this integral, which we said it was 1 over ln of x. So ln of x divided by ln of x is equal to 1. Okay, cool. And let me move the constant 1 to the other side. So we have I don't need to write this again. Just it will be simply 1 plus 1 over x. The integral from 1 to, this is ln of x right here. Okay, and then e to the t, t to the -1 dt. Okay, cool. Let me actually circle this so that we have, so this shows that psi prime of x is equal to the circle, and then obviously you know that 5x is equal to x, so that means the derivative of phi prime of x is just 1. Okay, cool. Nice. Just 1. Okay, so now let's actually plug everything together. Okay, so we have limit as x approaches infinity of psi of x divided by phi of x. Okay, so this is just 1 plus 1 over x, integral from 1 to ln of x, e to the t multiplied by t to the -1 dt, and then divided by 1. Okay, so I'm actually going to, so denominator is just 1, so we can actually just focus on just the numerator itself, but with this I'm actually going to rewrite it so that way we have a common denominator. So 1 is simply just x over x, and then plus 1 over x. So this means actually, since they have the same denominator, I can actually move that denominator down. So that means the limit as x approaches infinity. So that means we would get x, and then plus the integral from 1 to ln of x, e to the t times t to the -1 dt, and then divided by x. Okay, so take x approaches infinity. Notice that we also get, yet again, another infinity over infinity indeterminate form. So we have to apply L'Hopital's rule again. So this means we have the limit as x approaches infinity of this. Well, I was going to define a function, but I don't think that would be necessary since we have our pieces together. So obviously we know that when we take L'Hopital's rule, so when we take the derivative of the numerator, we get 1. And, well, okay, this is 1 here, so we can just simply just ignore that, so we can just focus on just the numerator. So this is the numerator, so derivative of x is just 1, and then plus we have the integral of 1 to ln of x e to the t times t to the negative 1 dt. We said that this was equal to, its derivative is equal to 1 over ln of x. So 1 over ln of x. And then take the limit as x approaches infinity. We get 1 plus 1 divided by infinity, which is 0. Therefore, it's 1. So, finally, the conclusion, the limit as x approaches infinity of ln of x divided by x multiplied by the integral of ln of x e to the t times t to the negative 1 dt is equal to 1. Like so. And there you have it. Pretty sweet, right?